What if our sun became a black hole? Our sun is too small, first of all, of a star to end its life as a black hole. But what would happen if the sun were suddenly replaced with a black hole of the same mass? Contrary to popular belief, the solar system would not be sucked in. A solar mass black hole would exert no more gravitational pull than our sun does. As this computer simulation shows, planets would actually continue on in their orbits as if nothing had happened. The thing is, of course, we wouldn't have any heat from solar radiation. Now, there's a conversation involving the same transcripts of Space Place Musings. What if the sun became a black hole? Narrator says, welcome to Space Place Musings, where an expert answers questions for our Space Place Museum partners across the nation. I'm Dan Fisher of the New Millennium Program. Our expert is Dr. Mark Raymond, scientist at the Jet Propulsion Laboratory. Mark, today we have a question on the subject that often fascinates people: black holes. It comes from the Paulucci Space Theater in Hibbing, Minnesota. And here it is. If the sun became a black hole, would Earth get pulled inside? Raymond says, interesting question. Black holes are just about the strangest objects known in the universe. Scientists call them holes, but they are anything but empty. They contain matter so compressed that the gravitational pull would not let even light escape them to reach our eyes and telescopes. That's why we can't see black holes directly, and so we call them black. Narrator, if the sun were a black hole, would we have no sunlight? We would have no sunlight, but what would its gravity do to us? Raymond says the gravitational pull of the sun, a black hole, or anything else for that matter, depends only on its mass and distance from us. So even if the sun were compressed to become a black hole, it would pull only as hard on Earth as it does now. Earth would not be pulled inside the sun, where if the sun were compressed to become a black hole. Narrator, so Earth would be safe. Now, if we cannot see black holes, how do we even know they exist? Raymond, because of the odd behavior of the matter near them that we can see. For example, gases swirl around these regions at nearly the speed of light, giving off lots of high energy radiation. Narrator, what does this swirling gas and radiation tell us? Raymond, well, for one thing, black holes come in vastly different sizes. Some contain huge amounts of matter, some contain much less. Narrator, how do they form? Raymond, some black holes form after a very large star uses up all its fuel and blows off its outer parts in a gigantic explosion called a supernova. Then what's left collapses under the weight of its own gravity to become a superdense object, a black hole. Our sun is actually too lightweight to end up as a black hole. It simply does not contain enough matter to exert that kind of gravitational force on itself. A star has to be more than about 10 times the mass of our sun to become a black hole. Narrator, so do black holes always contain at least this much matter? Raymond, well, not always. The key is that black holes in any amount of matter squeezed into a very, very dense package. Imagine all of planet Earth squeezed into the size of a marble. Earth would then be a black hole. Even I could be a black hole if I were compressed to be no more than 1,000 billion times smaller than a grain of salt. But you could still stand as close to me as you would for a normal conversation, and you would not fall into the marked black hole, because I would exert no more gravitational force than I do now. Narrator, if the sun could be compressed enough to become a black hole, how big would it be? Raymond, it would be less than 6 kilometers, well, under 4 miles across. It would exert no more gravitational force on Earth or the other planets in the solar system than it does now. Why? Because it would contain no more matter than it does now, and it would be no closer to the planets than it is now. Narrator, so how big can black holes be? Raymond says scientists have discovered that many galaxies have supermassive black holes in their centers. These enormous monsters may contain the masses of 100 million or more suns. A black hole that massive would be so large that if it were in the center of the solar system, where the sun is, it would extend beyond the orbits of Mars. Scientists are still trying to understand how common they are and how they may be found. At the other extreme, microscopic black holes may have formed in the early moments of the universe. Narrator: So if no light escapes them, how can scientists study black holes? Raymond: One way will be to study the gravitational waves some of them make in the fabric of space. NASA and the European Space Agency are working on some new technologies that will make it possible to detect gravitational waves using a space-based laser interferometer. The New Millennium Program Space Technology 7 project will develop and test one of the technologies that will be essential for making space-based gravitational wave astronomy possible. Narrator: Gravitational waves are a pretty exotic idea. Raymond: Yes, but not that difficult to understand. One of the articles on the Space Place website gives a simple explanation, along with a neat related activity for the classroom. To find it, our listeners can visit Space Place at nasa.gov, listening for rings from space. Narrator: Great suggestion, Mark. Then Space Place also has an interactive crossword puzzle. And this is on bended reality, but also, where do black holes lead to? Okay, all that matter goes into it, but what happens to that matter? Where does it go to? Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. So where do black hole lead to? So there you are, about to leap into a black hole. What could possibly await should, against all odds, you somehow survive? Where would you end up, and what tantalizing tales would you be able to regale if you managed to clamber your way back up, or somewhere survive? The simple answer is to all of these questions is, as Professor Richard Massey explains, who knows? As a Royal Society Researcher Fellow at the Institute of Computational Cosmology at Durham University, Massey is full aware of the mysteries of black holes. They run deep. He says falling through an event horizon is literally passing beyond the veil. Once someone falls past it, nobody could ever send a message back. He said they'd be ripped to pieces by the enormous gravity, so I doubt anyone falling through it would get anywhere. If that sounds like a disappointment and painful answer, then it is to be expected. Ever since Albert Einstein's general theory of relativity was considered to have predicted black holes by linking space-time with the action of gravity, it's been known that black holes result from the death of a massive star, leaving behind a small, dense remnant core, and assuming this core has more than roughly 3 times the mass of our sun, gravity would overwhelm to such a degree that it would fall in on itself into a single point, or a singularity, understood to be the black hole's infinitely dense core. The resulting uninhabitable black hole would have such a powerful gravitational pull that not even light could avoid it. So should you then find yourself at the event horizon, the point at which light and matter can only pass inward, as proposed by German astronomer Karl Schwarzschild, there is no escape. And according to Massey, tidal forces would reduce your body into strands of items, or spaghettification as it's known, and the object would eventually end up crushed at the singularity. The idea that you could pop out somewhere, perhaps at the other end, seems utterly fantastical. Now, what about a wormhole? Or is it? Over the years, scientists looked into possibility that black holes could be wormholes or to other galaxies. They may even be, as some have suggested, a path to another universe. Such an idea has been floated around for some time. Einstein teamed up with Nathan Rosen to theorize the Rosen Bridge, to connect 2 different points in space-time in 1935, but it gained some fresh ground in the 1980s when physicist Kip Thorne, one of the world's leading experts on the astrophysical implications of Einstein's general theory of relativity, raised a discussion about whether objects could physically travel through them. Reading Kip Thorne's popular book about wormholes is what first got me excited about physics as a child, Massey said, but it does not seem likely that wormholes exist. Indeed, Thorne, who lent his expert advice to the production team of the Hollywood movie Interstellar, wrote, "We see no objects in our universe that could become wormholes as they age." In his books, The Science of Interstellar, Thorne told Space.com that journeys through these theoretical tunnels would most likely remain science fiction, and there is certainly no firm evidence that a black hole could allow for such a passage. Please leave your comments and thank you for your support. This is Unvetted Reality.